Hello everyone and welcome to another simple science video where we aim to explain simple scientific concepts. And in this video we are looking at uniform acceleration equations or u+at equations. Here we go. In SAT and IGCSE physics we only deal with motion that has uniform acceleration. That means every motion will have uniform acceleration. The acceleration is constant, which in real life is not true at all. For example, if you're throwing a ball through the air, the faster you throw the ball, the greater its air resistance. But we are assuming that there is no air resistance, or the air resistance is constant no matter the speed. When you reach A-level mechanics, you will learn about variable acceleration, but we're not there yet. So we're going to deal with uniform acceleration. You must be familiar with these terms. As I've taught you in the last 5 videos, S is displacement, U is initial velocity, V is final velocity, and A is acceleration, and T is the time taken for this uniform acceleration. And these quantities, as you can read, u+at, can be used to form uniform acceleration equations or u+at equations. Okay, and let's look at the first one. V equals u at at. It is based on the concept that final speed v is equal to the initial speed u at at, which is the change of distance. Change of velocity. So let's look at the first question. A car initially travels with a velocity of 10 meters per second and accelerates at a rate of 5 meters per second squared. What is its velocity after 5 seconds? So you should set it up like this. Write down u+at and then write down what values you do know. So you do know that u, you know v, you know a, you know u, you know a, and you know t. So therefore you can use this equation, v equals u at at, and you can substitute the values in, and you should get 35 meters per second. So you must be able to know which equations to use by laying it out like how I did on the bottom left, u+at. Okay? And the second equation is v squared equals u squared at 2as. Okay? It is a very important equation that you can use to solve uniform acceleration equations where time taken is not given to you. So let's look at the first question. A car accelerates uniformly from 5 meters per second to 20 meters per second, covering a distance of 100 meters. Find its acceleration. So similarly, I'm going to lay it out u+at, and I'm going to write down what values I know, and I'm going to highlight A, because I'm trying to find A, and since I know S, U, V, and A, I can use this equation. I lay it out, v squared equals u squared at 2as. I rearrange the equation to find A. And I plug in all the values, and I should get 1.875 meters per second squared. Simple. So v squared equals u squared at 2as. Learn it. u+at equation number 3. S equals ut at half at squared. This is the most important u+at equation because it combines together all of the uniform acceleration concepts together. Okay, let's look at the first question. A car accelerates uniformly with a rate of 5 meters per second squared from rest for 5 seconds. Find the total displacement if its final velocity is 10 meters per second. So you lay it out, u+at S equals u v. Okay, sorry. And since you know all of the values, you can use u+at. So you laid out the equation. S equals ut at half at squared. So you substitute all the values in, and you should get S equals 62.5. You see, I said that its final velocity is 10 meters per second. In fact, that question is not needed. That fact is not needed in the calculation. So just beware. But overall, there are more u+at equations other than these three. But I basically compiled these three together because I felt that these are the most commonly used, and you can use these u+at equations to rearrange and combine them to form other u+at equations. But these are what I consider as the three most fundamental ones. So learn them. Okay, have a nice day.